The best way to review long division is to first do it with numbers. Let's say you wanted to do something like 521 divided by 4. You want to know what does that equal to, and we're going to figure it out using long division. So the way to do long division, we're going to put the numerator under the division sign, and then the denominator goes outside that long division sign. So that's how we would write 521 divided by 4. Then we ask ourselves, how many times does 4 go into 5? The answer is 1. So I put a 1 up here. I take that 1, I multiply times 4. 1 times 4 is 4. And then I subtract. 5 minus 4 is 1. And then I drop down the 2. I might as well drop down the 1 also. I can drop down everything to the right of it, and then I'm just going to repeat that process over and over again. This time I ask, how many times does 4 go into 12? The answer is 3 times. So I put a 3 up there. 3 times 4 is 12. This time when I subtract, I get 0. Oops. I'll drop the 1 down. And we're going to do it one more time. How many times does 4 go into 1? 0 times. 0 times 4 is 0. I subtract. 1 minus 0 is 1. And at this point, I have nothing more to drop down. I am done. The 1 is called the remainder. And the 130 is called the quotient. And what this is telling me is that my original fraction up here, 521 over 4, it's equal to the quotient 130 plus the remainder over 4. So in this case, 1 over 4. Okay, the remainder always is always part of it's always a fraction remainder that goes over the original denominator. So 521 divided by 4 is 130 plus 1/4, or if you wanted to write it as a mixed number, this is a really convenient way to do it. All right, now let's see, now that we've done it with numbers, let's try to do it with a polynomial. Let's try to do something like x cubed plus x divided by x minus 1. Okay, we want to figure out what is that equal to, and we're going to do long division to do it. We're going to write the numerator underneath the long division sign. We do have to be a little careful. We want to insert zeros for any places that are not accounted for in the numerator. Okay, we want to make sure every power of x is accounted for. That's going to help us to keep everything lined up when we're doing our long division. So if there's no x squared term, put a 0x squared in there. And then I'm going to put the x minus 1 out here. It's the denominator, just like the 4 was. Now I'm going to ask myself, now it's a little bit different question you ask yourself here. We're going to look at the x, we're going to look at the x cubed. We're going to ask ourselves, what do I got to multiply x by to get x cubed? The answer would be x squared. So I put an x squared there. Now I take that x squared, I multiply it times the x minus 1. If I do x squared times x minus 1, I'd get x cubed minus x squared. I'm going to subtract that just like I was doing over there with the numbers. X cubed minus x cubed is 0. That's by design. Then you got to be a little careful here. 0x cubed minus a minus x cubed would actually be a positive x cubed. As x squared, excuse me. I'm going to drop down everything to the right, and then I'm just going to keep on repeating that same process, just like we were doing with the numbers. This time I ask myself, what do I have to multiply x by to get x squared? The answer is x. I put an x here. I take that x, I multiply it times x minus 1. I'd have x squared minus x. I subtract. When I subtract, the x squareds go away. I do have x minus a minus x, so that's 2x. And we're going to do it one more time. What do I have to multiply x by to get 2x? This time the answer is 2. I take that 2, I multiply times the x minus 1. I'd have 2x minus 2. I subtract. This time I'd have 0 minus a minus 2, which is a positive 2. So now I've got my quotient on the top. I've got my remainder on the bottom. And I can write my original fraction as the quotient plus the remainder over the original denominator. That's the result of doing the long division there. This particular problem, there is also a little shortcut for doing this particular problem. If the denominator is of the form x minus a, instead of doing long division, you can actually simplify this a little bit by doing synthetic division. Okay, here's how you do synthetic division. It's the same thing as long division, just a little bit less writing. The fact that the denominator here is x minus 1, it's kind of like a is 1. I start by writing a 1. Then I'm going to draw, it's a little bit different notation, but I'm going to, what I'm going to do is I'm going to put the coefficients of my numerator right now, and I'm going to include those zeros just like I did when I did the long division. So the coefficients of the numerator there would be 1, 0, 1, 0. The way to do synthetic division is to start off by dropping down this first coefficient here, so 1. We do 1, then we're going to multiply these two together. 1 times 1 is 1. We're going to put that here, and this time we're going to add. 0 plus 1 is 1. And then we're going to repeat that same process. 1 times 1 is 1. So I put that there. And then 1 plus 1 is 2. I add. And then I do it one more time. This time 2 times 1 is 2. 0 plus 2 is 2. And what this has given me, what this tells me is the last number, once again, is the remainder. The remainder is 2, just like it was with the long division. And everything before the remainder is telling me the coefficients of the quotients. The coefficients of the quotient, which in this case are 1, 1, and 2, which tells me that my answer was 1x squared plus 1x plus 2. So these are the coefficients of the quotient. So a lot less writing, you get the same answer. Synthetic division is a nice shortcut. It only works when your denominator is of the form x minus a.